In order to start with that, I think I took some basic concepts. So first concept is Occam razor, that entities should be not multiplied beyond necessity. That means if you create something, it should make something. So try to optimize and try to make everything most efficient way. That means every operator should change something in your project. We will turn back to this topic a lot of times during the workshop, but I wanted to declare that. Second thing, in order to work efficiently, you have to divide and conquer. So basically, the realization of this quote in computer programming world is a model view controller paradigm. That means that you separate your work on logical modules. And both TouchDesigner and Houdini are very oriented to modular work, where you can create building blocks of higher level, and that way you can create reusable parts. So we will also speak a lot about how to structure your work. And last thing, before we start with a bit more interesting visual examples, what is, for my opinion, the logical task definition? If you would say, for example, I want my mouse position on the screen will control the circle radius. Basically, that sentence already contains all amount of operators needed to solve this task. So basically, if you can bring what you want to make not only to verbal level but also to that logical level where you precisely define what you want to achieve, you can create the result. So I will visualize now what I mean. But basically, from my experience, I see that a lot of people have struggled achieving some results because they cannot explain what they want on that logical level. And because of that, they always asking question, for example, is it possible to make that and that? My answer to that is yes, everything is possible if you can precisely define the task, because both TouchDesigner and Houdini are basically the visual programming environments. So that is not just a 3D programs or programs for making generative visual art. Both these programs are visual programming languages, and they're flexible enough to solve any possible task you can imagine. That is only the question of task definition. So let me make a small example. So we say we want that mouse position on the screen controls the size of the circle. So first we know that we need circle. Let's look for that. We can find all possible operators in this op-create dialog. Both in TouchDesigner and in Houdini we have the same approach. We always print tab on keyboard and we invoke the dialog where we can find all possible operators we can create. So we go and think, okay, let's create a circle. Now, how we can change the radius of circle? We can find that circle has parameters which can control its behavior. And we can control these parameters by hand, by mouse, or we can automate the controlling of parameters. So basically all interactive tasks, always if you want to create something interactive reacting to sound, to interactive sensors data, to web data, to animation scheduled on time, or any other rules, that's basically on language of TouchDesigner as well as Houdini, is just how we can change some parameter of some operator. So basically everything what we are doing, we creating operators and changing their parameters. Doesn't matter if it's created by it's that parameters changed by nodes or they changed by the scripts, expressions. That's all only about to change parameters. So that's super simple. Then okay, if we know we have a circle, now we want to control its radius by the mouse position. So we need somehow to capture mouse position. For that we have mouse in operation. I don't go now to explain what is the difference between green operators and blue operators, because we have the additional lesson for that, but I just want to show the basic workflow. So mouse in, and we see, yes, that's green operator called chop, mouse in chop, returns the mouse position on the screen. So now we can basically connect that value tx to the radius of the circle. Only thing, if we connect that directly, we will obviously control that circle radius on a weird way, because we can see that the values are in different range. So now we can see that if I bring my mouse to the left side, that green operator returns value of -1 almost, and it goes until almost 1 in positive range. And if I do the same with a radius, it will sweep and in some moment fill the space of picture completely. So that is not what I want. So then in our sentence we said we want to control the radius of circle by the mouse position. We need to add some additional rule. We have to define the range where the left position should correspond to the radius of 0, let's say 0.02, and in right position it will correspond to, let's say, something like 0.4. So in order to make that, we have to look for operator which can make this range matching, and that operator is met. So here we can find the from range to range. So we change -1 to 1 to the range of 0.02 until 0.4, and then we can connect this channel to the radius parameter, and we see that our result is ready. So basically that is a main workflow how we can solve interactive task using TouchDesigner, and basically the same way it works also in Houdini. Most important thing here is to understand how we can convert the human language to the language of TouchDesigner. That was a super fast introduction to the topic. What I want to add, that basically here we have kind of building blocks. If I turn back to the picture I already shown, model, view and controller. User is me controlling the model. Model, it will be the engine producing our result. Controller in this sense will be these two operators. So I can even bring it now to the inside of annotate block, so they are visually separated. That will be a controller, and that operator now contains both model and view representation. But actually going a bit in advance, that actually is a model, and where we bring this result, this rendered animation, we can bring it to the another screen, to the beamer. We can render it to the movie to the hard drive. That will be another model which is view. So for example, I can make a window and represent the result in a window, which I can open in another screen of my machine, or I can output the result to the movie, to the hard drive, movie file out. And in this case you can see that basically that will be model, the thing producing the result, and that will be the view, the visualization of result which can be seen by other people. And if we start to think in these categories from the very simple project, we can build very flexible applications, because these three things are actually don't connected to each other directly. We can always switch where we output the results. This is also the concept of procedural graphics.